Assalamualaikum, my name is Siti Fazana S75955. We present about UV spectroscopy study in acoustic analysis of waveforms K-based complex. In this video, I will briefly introduce the waveforms K-based complex, the determination of acoustic number, acoustic table, and the symbol, and also how to determine the transition in UV spectrum using the Sugano diagram. I choose the waveform complex to be analysis. Vanadium 4 commonly exists as the vanadium ion or VO2+. Its metal center is typically coordinated in distorted octahedral or square pyramidal geometry due to presence of a strong V double bond. The number of possible electronic transitions is limited because only one d electron is present. Thus, make the V4 ion possesses a d1 electronic configuration. The generality of d orbital is removed by the LIGO field, so the splitting of the 2d free atom into 2dg ground state and the 2eg eccentric state. Now, how can we determine the acoustic number? So first, we need to find the atomic number of vanadium, which is 23. 23 atomic number will give 1s2, 2s2, 36, 3s2, 3p6, 4s2, and 33 electronic configuration. Since the oscillation state of vanadium in this complex is +4, we will remove 4 electrons, 2 from 4s2 orbital and 2 from 3d3 orbital. Then we will get a d1 configuration. Next is acoustic number calculation. There is 5 orbitals in d orbital and each of that have 2 spins. Using the formula, we will get 10 as a acoustic number. Next, I will explain about how we can construct a acoustic table. But first, we need to construct a acoustic diagram. So, there are 2 possible states in each d orbital, spin up and spin down. Based on the diagram, you can see all possible combinations of orbital angular momentum quantum number ml and spin quantum ms for a single d electron. The ml represents +2, +1, 0, -1, and -2. So, each of it will contain either spin up or spin down. After we're done, we need to determine the acoustic. So, for spin up, we will put a plus charge on the ml, which will be +2+, +1+, and so on with others. It will be vice versa with spin down, which we will put a negative charge. Based on the table, we will see all the lists of allowed combination of ml and ms for d1 electron. The row represents the spin state, while the column represents the orbital angular momentum values. Each cell in the table represents 1 acoustic, and so we will get a total of 10 acoustics. A term symbol is written in the form 2s plus 1l, where s represents the total spin quantum number and l represents the total orbital angular momentum quantum number. For a d1 configuration, the total spin s is 1/2, resulting in a spin multiplicity of 2. The orbital angular momentum quantum number l for a d electron is 2, which corresponds to the spectroscopic letter d. Therefore, the free atom symbol for V4 is duplet d. In an octahedral Ligand field, the duplet d free atom split into a lower energy 2Tg ground state and a higher energy 2Eg eccentric state. According to the Sugano diagram for a D1 system, only one spin allowed. Electronic transition is expected. Thus, the absorption band observed in the UV visible spectrum is assigned to the 2Tg to E2G electronic transition. In conclusion, the UV visible spectroscopic behavior of the V4 K-based complex is consistent with its D1 electronic configuration. The acoustic analysis, the symbol determination, and the Sugano diagram collectively support the study of the observed absorption band to the 2Tg to EG transition. That's all for me. Thank you.